Hey friends, welcome back to CodeOps Trek. Today, we will learn how to build a REST API with Spring Boot, connected to MySQL running in Docker. This tutorial is perfect for beginners and will give you a hands-on understanding of how APIs work. So let's get started. Before we start, let's discuss what a REST API is. REST, which stands for Representational State Transfer, is an architectural style for designing networked applications. It relies on a stateless, client-server communication model and uses standard HTTP methods such as GET, POST, PUT, and DELETE to interact with resources. In a REST API, resources are represented by URIs, and the data exchanged is typically in formats like JSON or XML. One of the key principles of REST is that it is stateless, meaning each request from a client to the server must contain all the information needed to understand and process the request. This allows for scalability and improves the performance of applications. REST APIs are widely used due to their simplicity, scalability, and ability to integrate with various platforms and services. Now that we have a basic understanding of REST APIs, let's start our tutorial. In this tutorial, we will build a simple student management system with basic CRUD operations which are create, read, update, and delete, using Spring Boot for the backend and MySQL as our database, running inside Docker. Think of it as a project where you'll manage students' information, like their ID, name, date of birth, and parents' details. It's a practical example, and by the end, you'll have a fully working REST API that you can use for any other project. We will break this project into 3 main parts, making it easier to follow along. First, we'll set up MySQL in Docker and create a database called Student Management. Second, we'll create a REST API in Java using Spring Boot. We'll cover everything, from models to data access layers, services, and controllers. Finally, we'll test everything using Postman to ensure our API works as expected. Let's start with setting up our MySQL database in Docker. Before setting up MySQL, ensure Docker is installed on your system. Now, open your terminal and run docker pull MySQL command to pull Docker image. If no tag is specified, Docker will pull the image with the default tag, which is latest. Next, we need to run this Docker image to create a container. Use the following command to run Docker image. This command will create a container and name it as MySQL container, maps port 3306 inside the container to port 3309 on your host, sets the root password to root, and runs the container in the background. The container will be created and started in a short time. To check if the container is running and to see the port bindings, use the command docker ps. In the output, you should see MySQL container listed as a running container with port 3309 on your host system, mapped to port 3306 inside the container. Next, we will enter into the Docker container. Use following command to enter the container. Once inside, log into MySQL using mysql-uroot-proot. Now we are inside the MySQL terminal. To see the existing databases, run the following command. Show databases. Next, we will create our student management database with the command. Create database student management. To switch to this database, use student management. If we check the tables now with show tables, you'll see there aren't any table because it's a fresh database. That's how we've set up MySQL in Docker, completing the first part of our tutorial. Now, let's move on to the exciting part, creating a REST API with Spring Boot. First, we will head over to Spring Initializer. Here, you'll see a form where you can select options like the language, build type, and version. For this project, we'll keep it simple. Select Java as the language, Maven as the build type, and keep selected the Spring Boot version. Next, update the project metadata, set the group name to com.student, project name to student management, and the package name also to com.student. Now, it's time to add the dependencies. For this project, we'll need Spring Web, Spring Data JPA, and MySQL driver. Once you've selected these, double-check everything is correct, and then click Generate to download the project files. Next, let's create a workspace for our project. Name it Student Management Workspace. Once that's done, head over to your Downloads folder where the Spring Boot project was downloaded. Extract the zip file into the created workspace. This will set up all the project files we need in one place, making it easier to manage and work with throughout the development process. Now, open Eclipse and select the Student Management Workspace you just created. Launch your Spring Boot application from there. Next, go to File and choose Open Project from File System. Select your extracted project Student Management and click Finish. Your project will now be imported into Eclipse. Spring will automatically download all the required dependencies based on your internet connection, so ensure your system is connected. There's one important setting to configure: setting up code assistance. To do this, go to Window, then Preferences, then Java, and under Editor, click on Code Assist. In the Triggers for Java section, type A to Z to enable better code suggestions. This will help streamline your coding experience. Before jumping into the code, let's first understand the layers in our application. This is the architecture diagram for our student management application, which connects to MySQL running in Docker. At the heart of the application is the student class, which has attributes like ID, name, date of birth, father's name, and mother's name. Our application will follow a layered approach with three main layers: the DAO layer, the service layer, and the controller layer. First, we have the DAO layer, short for Data Access Object. This layer is responsible for interacting directly with the database to perform all CRUD operations. It's essentially an interface that allows us to connect to the database. Next is the service layer, which implements the logic defined in the DAO layer. Finally, we have the controller layer, where all our REST APIs will be created. Now, let's walk through the flow of the application with an example. Let's say we want to fetch a student by their ID using an API called getStudentById. When this API is called, the request first lands in the controller. The controller then reaches out to the service layer, which in turn calls the DAO layer. The DAO layer executes the necessary SQL query behind the scenes, retrieves the data, maps it to the student object, and passes it back to the service layer. The service layer then returns the student object to the controller, which sends the data back in the response. This flow ensures a clean separation of concerns, making the application easier to maintain and extend. Now that we understand the architecture, let's move on to the coding part. Before we dive into coding, let's quickly go through the project structure of our student management application. We'll highlight the important folders and files that we'll be using frequently. First, there's the Java package under the main directory. This is where we'll place our models, repositories, controllers, and services. Next, we have the resources package, also under the main directory. This package contains static files like images and the properties file, where we define important application properties like the port, database URL, username, password, and more. We also have the Java package under the test directory, where we'll write our test cases. Finally, there's the pom.xml file. This file contains all the project dependencies, managing everything needed for our Spring Boot application to work properly. First, let's create our student class. Start by creating a new package under the Java folder and name it model. Inside this package, create a new class called student. Now, let's define the properties of the student. The first property will be ID, which will be a private integer. Next, we have name, a private string. Then, we'll add date of birth, another private string, followed by father's name and mother's name, both of which will also be private strings. Since these properties are private, we need a way to access them from outside the class. For that, we'll generate constructors, getters, setters, and a toString method. Eclipse makes this easy. Go to source, click on generate constructor using superclass, and Eclipse will handle it for you. Do the same for generate constructor using fields. Now, let's generate the getters and setters. Go to source, click generate getters and setters, select all the fields, and click generate. Finally, generate the toString method by going to source and clicking generate toString. Once that's done, format the code by pressing Ctrl+Shift+F. And just like that, we have created our student class. Now, let's create our student class as an entity, which will be mapped to a database table. At the top of the class, we'll use the @entity annotation to tell Spring that this class represents a database entity. For our ID field, we'll mark it with the @ID annotation to specify that this field is the primary key, and we'll use @generated value, strategy generation type.auto, to automatically generate the ID whenever a new student record is added to the database. Finally, we've created a fully annotated student class that's ready to interact with our database. Next, we will create the first layer of our application, which is the DAO layer, also known as the Data Access Object layer. This layer is responsible for all the interactions with the database, handling read and write operations. Essentially, this layer is an interface that allows us to abstract these database operations. Let's start by creating a new package under com.student and name it DAO. Inside the DAO package, we will create an interface called Student Repository. This interface will extend JPA repository, which provides all the basic CRUD operations for our entity. The JPA repository takes two parameters, the student object, which is the entity we just created, and the type of the primary key, which in our case is an integer. With this, our DAO layer is complete. It's directly connected to the database and will handle all the reading and writing of student data without us having to write SQL queries ourselves, as JPA repository takes care of that. Now, let's move on to the next layer, which is the service layer. This layer acts as a middleman between the controller and the DAO layer. It contains the business logic of our application and utilizes the DAO layer to perform database operations. First, we'll create a new package under com.student and name it service. Inside this package, we'll define a class called student service. To mark this class as a service, we'll annotate it with @service above the class declaration. Additionally, we'll auto-wire the student repository by annotating the repository field with @autowired. This will automatically inject the repository, allowing us to connect to the database and perform operations without explicitly creating repository instances. We'll start by creating a method that will save a student into the database. The method will be public and return the saved student object. We'll name the method saveStudent, and it will accept a student object as a parameter. The save method of the student repository will take the student object as an argument, persist it to the database, and return the saved student. This allows us to confirm that the student has been successfully stored. Next, we will create a method to retrieve all students. The return type will be a list student, and the method name will be getListudents. Inside the method, we will simply return student repository.findAll, which fetches all student records from the database. Next, we'll create a method to retrieve a student by their ID in the service layer. This method will be public with the return type student, and the method name will be getStudentById. It will accept student ID as a parameter, and inside the method, we'll use student repository.findById, student ID, or else, null, to fetch the student from the database. If no student is associated with the provided ID, it will return null. To update an existing student, we'll create a method similar to the save method, but this one will handle updates. The return type of this method will still be student, and it will take the updated student object as a parameter. Inside this method, we'll update their details and save the changes back to the database. If the student doesn't exist, we can handle that scenario accordingly, perhaps by throwing an exception or returning a specific response. Finally, we'll return the updated student object after it's saved. Lastly, to delete a student, we'll create a method with a void return type, as no data will be returned upon deletion. The method will be named deleteStudentById and will take an integer student ID as a parameter. Inside this method, we'll call the deleteById method from the student repository, which takes the student ID as an argument and removes the corresponding student from the database. Since the return type is void, no response will be given, but the operation will successfully delete the student from the system. That's how we have completed the second layer of the application. Now, let's move on to the third and final layer, which is the controller layer. This layer handles the incoming HTTP requests and maps them to the corresponding service methods. It acts as the entry point for the client to interact with our application. First, we'll create a new package under com.student and name it controller. Inside this package, we'll define a class called studentController. We'll mark this class with the @REST_controller annotation, indicating that it will handle REST API requests. We'll also use the @request_mapping annotation at the class level to map the base URL path for all endpoints related to the student service. In our case, the base path will be student service. Next, we will create an object of student service by using the @autowired annotation. This will allow Spring to inject the student service automatically, enabling us to call its methods to handle the business logic in our controller. Here's how the autowiring will look. Next, we'll start by creating the first API for saving a student to the database. The method will be public with a return type of student. It will be named SaveStudent and will accept a student object as a parameter. To bind the incoming JSON body to this method parameter, we'll annotate the student parameter with @requestBody. Additionally, the method will be annotated with @postmapping, specifying that this API endpoint will be accessible via an HTTP POST request. Inside the method, we will call the SaveStudent method from the student service. This API will now accept a POST request with student data in JSON format and save it to the database, returning the saved student as a response. Next, we'll create an API to retrieve all students from the database. The method will be public with a return type of list of student. It will be named getStudents and will be annotated with @getMapping, indicating that it will be accessed via an HTTP GET request. Inside this method, we will call the getStudents method from the student service, which retrieves the list of all students from the database, and then return that list as the response. Here's how the code looks. Similarly, to retrieve a student by their ID, we'll define a method with the @getMapping annotation, passing the ID as a path variable. This method will be public, and the return type will be student. It will be named getStudentById, and the student ID will be passed as a parameter. The parameter will be annotated with @path variable to bind the value from the URL. Inside this method, we will call the getStudentById method from the student service, passing the student ID and returning the retrieved student. To update a student, we'll create a method similar to the SaveStudent method, but instead of @postmapping, we'll use @putMapping to indicate that this API will handle HTTP put requests. The method will be public, with a return type of student, and will be named updateStudent. It will accept a student object as a parameter, which contains the updated information. Inside the method, we will call the SaveStudent method from the student service, passing the updated student object and returning the result. Finally, we'll create an API to delete a student by their ID. This method will be public with a void return type, as nothing will be returned upon deletion. The method name will be deleteStudentById. The student ID will be passed as a path variable using the @path variable annotation. It will be annotated with @delete mapping to indicate that it handles HTTP delete requests. Inside the method, we will call the deleteStudentById method from the student service and pass the student ID to delete the corresponding student from the database. That's how we have completed the third layer of the application. Next, we'll add some configuration settings in the application.properties file. Head over to the resources folder in your project and open or create the application.properties file. In the application.properties file, we configure key aspects of the application, such as the server port, database connection, and Hibernate settings. The server runs on port 8080, while the database connection settings define how to connect to a MySQL database, student_management, using the specified URL, username, and password. Hibernate settings like showSQL true allow SQL queries to be printed for easier debugging, and DDL auto update automatically updates the database schema based on entity changes. Before we start our application, let's check the state of our database. Since this is a new database, you'll find that there are no tables currently present. However, once we start our application, Spring Boot will automatically create tables based on the classes annotated with @entity. It's important to note that Spring will not recreate the tables every time the application starts. This behavior is determined by the spring.jpa.hibernate.ddlauto property in the configuration. If it's set to update, only changes will be applied, but the existing data and tables will remain intact. Now, let's start our application. Open the Student Management project, right-click on it, and select Run as Java application. Spring Boot will take a couple of minutes to start, and during this process, it will connect to the database and generate the required tables for our student entity. Our application has started successfully. Now, let's verify whether the table has been created. In the MySQL terminal, type show tables, and you should see the student table listed. Congratulations, our student table is now created. Next, let's check if there's any data in the table. Type select star from student, and you'll notice that there are no records, which is expected since we haven't inserted any data yet. With that, we've completed the part of our tutorial, where we successfully set up the application and connected it to the database. Moving towards the final part of our tutorial, we'll now test our APIs using Postman. First, open your Postman application and create a new workspace, naming it Student Collection. To test the first API, which saves a student, create a new request and name it Save Student. Set the HTTP method to post and enter the URL as http://localhost:8080/student-service/save-student. In the body section, select raw and choose JSON format. Then, input a sample student JSON object. When testing the API, it's important to ensure that the JSON object keys exactly match the parameter names defined in the student class. For instance, if our student class has fields like name, date of birth, father name, mother name, the JSON object in Postman should reflect the same. We can ignore ID as it is auto-generated and handled by MySQL itself. After creating the JSON body with the appropriate data in Postman, hit the Send button. You will receive a response containing the student object, including the automatically generated ID set by MySQL. This confirms that the student was saved successfully. Now, return to the MySQL terminal to verify the data. Type show tables to ensure the student table exists, and then type select from student to check if the student record has been successfully stored in the database. Similarly, we will add a few more student records in Postman for further API testing. By creating additional JSON bodies with different student data and hitting the Send button, you can insert multiple records into the database. Each time, the response will return a student object with a unique ID assigned by MySQL. After saving these records, you can go back to the MySQL terminal, run select from student, and verify that all the records have been successfully added to the student table. Next, we will test our second API, which is to retrieve all students. In Postman, create a new request and name it Get All Students. Select the method type as get and set the URL to student service/getAllStudents. After hitting the send button, you will see a list of all students that were previously stored using the first API. The response will display the entire list of student records from the database in JSON format. Next, we will test our third API, which retrieves a student by their ID. In Postman, create a new request and name it getStudentById. Select the method type as get and set the URL to student service/getStudent/ID. After hitting the send button, you will receive the details of the student associated with that ID in the response, confirming the successful retrieval from the database. Next, we will test our fourth API, which is used to update a student. In Postman, create a new request and name it updateStudent. Select the method type as put and set the URL to student service/updateStudent. In the request body, take any existing student record from the getAllStudents API response and modify the student's name or any other field you'd like to update. After hitting the send button, you will see the updated student details in the response. To confirm, you can call the getAllStudents API again to verify that the changes have been successfully saved. That's how we have completed this tutorial. You can check out following the same configurations in our blog. Just pick a different student from the next video where we'll demonstrate how to Dockerize our Java fields you want to update in the request body. Please like and hit the share button and subscribe to our channel. You will again receive the updated student details in the response, and you can verify the changes by calling the getAllStudents API. Finally, we will test our last API, which is the delete API. Create a new request, name it deleteStudent, select the method type as delete, and provide the URL as student service/deleteStudentById, passing 3 as the student ID to delete the third student. After hitting the send button, the student with the given ID will be removed from the database. You can confirm the deletion by using the getAllStudents API to check if the student has been successfully removed from the list. That's how we have completed this tutorial. You can check out all the code and configurations in our blog. Don't miss our next video where we'll demonstrate how to Dockerize our Java application. Please like, share, and subscribe to our channel, CodeOps Trek.